an Indian company made a solemn, written promise to China. The materials were for electric cars, for peaceful factories, for civilian use only. China believed them and shipped 120 tons of the world's most strategically valuable materials. Then those materials vanished, repackaged, relabeled, rerouted into military drones, missile systems, and Western defense labs. But here's what nobody expected. China had been watching every single gram, the whole time. And what Beijing revealed next sent shockwaves through the entire global supply chain. Before we get into the deception, the tracking system, and the explosive diplomatic fallout, we need to establish something fundamental. Because without understanding what rare earths actually are and why they matter so deeply, the rest of this story won't land the way it should. Rare earth elements are a group of 17 metallic materials with names most people have never said out loud: neodymium, dysprosium, terbium, samarium, gadolinium. In raw form, they look completely unremarkable. Dull gray powders, small metallic fragments. Nothing about their appearance suggests that they sit at the absolute center of 21st century industrial and military power. But they do. The electric motor in your EV almost certainly contains neodymium and dysprosium. The guidance system in a precision missile runs on terbium and samarium. Radar arrays on modern fighter jets, wind turbines, hard drives, smartphone speakers. Every one of these technologies depends on rare earths in ways that cannot currently be substituted or worked around. And here is the geopolitical reality that makes everything in this story so charged. China controls them. Not partially, not significantly, almost completely. Approximately 90% of the world's rare earth refining and separation capacity sits inside China. For medium and heavy rare earths, the subcategory that includes the most militarily critical elements, China's dominance is even more absolute. The United States has been trying to rebuild domestic rare earth processing for years. Australia has been developing its deposits, but the gap between what the rest of the world can refine and what China produces every year remains enormous. This wasn't an accident. China identified rare earth processing as a strategic national asset decades before the rest of the world fully grasped what that meant. It built the refineries, trained the engineers, established the supply chains, and now, as global demand for rare earths explodes alongside the clean energy transition and military technology race, Beijing holds leverage of almost unparalleled strategic depth. And in 2024, China began using that leverage in ways the world hadn't seen before. In April 2024, China placed 7 types of medium and heavy rare earths under strict export license management, including samarium and gadolinium. The controls covered not just raw ore, but processed oxides, alloys, and finished magnetic materials. You couldn't simply import Chinese rare earths, do minimal processing, and re-export them without triggering the license requirement. 6 months later, Beijing expanded the restricted list by 5 more elements, including holmium and europium, bringing the controlled total to 12 types. And then came a rule that changed everything. China announced that any foreign-made product containing Chinese rare earths, if the Chinese origin component exceeds just 0.1% of the product's composition, must apply for a Chinese export license before being re-exported anywhere. Think about what that means. A manufacturer in France uses Chinese dysprosium in a defense component. That component goes into a weapon system. Under this rule, the entire export chain falls within Beijing's licensing jurisdiction. The rare earth doesn't lose its Chinese identity when it crosses a border. It carries that identity through every subsequent transformation, in every country, all the way to the end product. The approval numbers made the strategy unmistakably clear. Over 10,000 overseas companies submitted import license applications for Chinese rare earths. Fewer than 1,500 were approved, roughly 15%. In September 2025 alone, 141 German companies applied. only 19 received approval. A 13% success rate for sophisticated, compliance-conscious industrial operators with legitimate manufacturing needs. For American companies, the scrutiny was even sharper. Dexter Magnetic Technologies submitted 180 license applications. It received approval for 5, under 3%. Meanwhile, nations with warm diplomatic ties to Beijing, like Serbia, saw their compliant orders largely unaffected. The message from China was consistent and deliberate. Access to Chinese rare earths is not a neutral commercial transaction. It is a direct function of your diplomatic relationship with Beijing. It was inside this environment of tightening controls and escalating tension that one Indian company decided to take an extraordinary risk. Sona BLW Precision Forgings, known as Sona Comstar, is one of India's most respected automotive components manufacturers. Headquartered in Gurugram, the company supplies drivetrain and electro-drive systems to global automakers, including Ford and Stellantis. In 2025, it expanded aggressively into India's rail sector, acquiring Escorts Kubota's railway equipment division and beginning to supply brakes, couplers, and suspension systems to Indian railways. Every single one of those products, automotive motors, rail equipment, precision electromagnetic components, depends on high-purity rare earths. And here is India's structural problem. The country has rare earth deposits in the ground, but almost no capacity to refine them to usable industrial purity. The highest purity India's domestic processing can currently achieve is around 82%. That falls well short of the 99% plus purity required for advanced manufacturing. And even at that lower standard, Indian refining costs run 3 to 4 times higher than Chinese equivalents. For Sona Comstar, the dependency on Chinese rare earths wasn't a preference, it was an industrial necessity. So between mid-2024 and early 2025, Sona Comstar submitted 30 formal end-use undertakings to Chinese export control authorities. These are legally binding declarations. In every single one of those 30 documents, the company stated the same thing. The rare earths would be used exclusively for electric vehicle motor component production within India. Civilian applications, peaceful manufacturing, clean energy industry. On the strength of those declarations, China approved the imports. A total of 120 tons of rare earth materials were cleared and shipped. The paperwork was in order. The stated purpose was consistent with the company's public business profile. The deal looked legitimate from every angle. And then the cargo arrived in Mumbai and went somewhere it was never supposed to go. When the shipment reached Mumbai port, it didn't go to Sona Comstar's production facilities. The delivery address stated in the approved documentation received nothing. Instead, the cargo was quietly transferred onto another vessel bound for Southeast Asian waters. What followed was a carefully planned multi-stage operation to erase the material's identity and history, the process that trade compliance experts call origin washing. In warehouses across Malaysia and Vietnam, the rare earths were offloaded, transferred into new containers, and relabeled. Materials stamped Made in China in the original export documents were now being marketed as Made in India, processed goods from Indian industrial operations, not Chinese mines. The markup applied during this process was approximately 60%. Materials purchased at Chinese export prices were being resold at significantly higher values, the premium that Western defense buyers were willing to pay for materials that could pass compliance checks as non-Chinese origin. By early 2025, the disguised rare earths had been split into 2 separate streams. The first stream went directly to Indian defense contractors. A portion of the reprocessed materials was incorporated into components for core Indian weapons systems, including the Heron military drone and the Dauntless surface-to-air missile program. These aren't peripheral projects. The Heron is one of India's primary military surveillance and strike platforms. The Dauntless is central to India's air defense architecture. Chinese rare earths, imported under civilian use declarations, were now inside Indian military hardware. The second stream went westward. Repackaged with documentation suggesting Malaysian or Vietnamese origin, a portion of the materials was sold to U.S. defense contractors and French military research laboratories. The buyers presumably believed they were purchasing legitimately sourced rare earths from neutral third-country suppliers. In reality, they were acquiring Chinese origin materials that had been laundered through an elaborate multi-country disguise. By June 2025, China had officially uncovered the entire operation. Beijing immediately halted all rare earth exports to the companies involved and placed them on China's rare earth trade blacklist, a designation with severe and lasting commercial consequences in a market where Chinese supply is essentially irreplaceable. But the question everyone was asking, the question you're almost certainly asking right now, is how? How did China reconstruct the journey of 120 tons of material across 3 continents, through multiple transfers, after sophisticated repackaging, under fake documentation? What kind of system makes that possible? The answer wasn't something Beijing improvised in response to this incident. It was the product of years of deliberate, large-scale investment in supply chain surveillance infrastructure. An investment that came to full operational capability in 2025. In June 2024, China formally announced a plan to build a comprehensive rare earth product information tracking system. The objective was explicit: full life cycle traceability from the moment of extraction to the point of final use. Through a management model Beijing called One Item, One Code. The system's first major enforcement tool was the quarterly verification requirement introduced with the April 2025 controls. Beyond the existing license approval process, Beijing added a new mandatory rule. Every importing company must submit documented proof of actual end use every 3 months, not paperwork promises, real evidence, production orders, shipment records, end customer information. All of it had to match precisely with the original end-use commitment letter. This rule was designed to catch exactly what Sona Comstar was doing. The company had declared civilian EV motor production. When the first 3-month verification window arrived, it needed to prove those rare earths had actually been used that way. It couldn't. There were no purchase contracts with automakers. No shipment records for EV components. The downstream data that should have matched the declared civilian applications simply didn't exist. Facing inevitable exposure, Sona Comstar was forced to rush its resale timeline. What had been planned as a gradual 6-month distribution was compressed into less than 2 months of frantic transactions, leaving additional forensic traces that made the investigation even easier. But the second mechanism was where China's technical capability became truly extraordinary. At the core of the tracking system is what amounts to a GPS permanently embedded in the rare earth material itself. In major production regions like Ganzhou in Jiangxi Province and Inner Mongolia, every batch of raw material is embedded with a passive RFID electronic tag the moment it is extracted from the ore. These tags are encoded using China's SM4 state encryption algorithm, a military-grade cryptographic standard. The data written at extraction includes the geographic coordinates of the mining site, the exact time of extraction, and the ore grade classification. Once written, that data cannot be altered. The origin record is locked into the tag at the source. As the material moves through refining and processing, the system automatically updates the record through read-write devices installed along production lines, adding processing details, quality grades, and inspection results at each stage. During transportation, vehicle-mounted readers work with GPS modules to continuously upload the route in real time, monitoring whether the cargo deviates from its authorized path into unauthorized facilities or unexpected destinations. Now apply that to the Sona Comstar case. Even after those 120 tons crossed the ocean to Mumbai, were transferred to a second vessel, sailed to Southeast Asia, were offloaded into Malaysian and Vietnamese warehouses, repackaged into new containers, and relabeled as Indian origin goods, The RFID tracking data from the original Chinese extraction point was still embedded in the material. The physical tags traveled through every layer of the disguise operation. China's system could reconstruct the entire route not by tracking containers or ships, but by tracking the material itself. By August 2025, this system had been deployed across 98% of China's key rare earth enterprises. The post-export blind spot that had made operations like this theoretically possible was closed. The fingerprint that cannot be faked. But sophisticated actors could theoretically strip RFID tags, remove them, damage them. What then? China had anticipated this. And the answer lies in something that cannot be manufactured, removed, or counterfeited: the geological identity of the Earth itself. The second core capability of China's surveillance system is isotope fingerprint tracing. Rare earth elements like dysprosium and terbium contain multiple stable isotopes. The geological environment of each mining deposit, the specific combination of pressure, temperature, and chemical conditions that formed over millions of years, produces unique isotope ratios in the materials extracted from that location. These ratios are as distinct to their origin as a human fingerprint. Chinese scientists have spent years building a comprehensive database of isotopic profiles from the country's major rare earth production zones. By analyzing the isotopic distribution of any rare earth sample, investigators can now match it back to its original mining source. Even if the physical tags have been removed, even if the packaging has been replaced, even if the documentation claims the material came from India or Malaysia or anywhere else, the material cannot lie about where it came from. Its geological history is encoded in its atomic structure. No amount of relabeling changes the isotopes. Combined, the RFID life cycle tracking and the isotope fingerprint database, these two systems give China dual-layer identification on every batch of rare earth it exports. It can see where the material went, and it can prove where it came from. Together, they close almost every avenue through which origin washing could succeed. The diplomatic fallout. When China disclosed what it had found, India's response was telling. Rather than address the specific violations, investigate the diversion, or acknowledge what Chinese authorities had documented, Indian officials went on offense, publicly accusing China of weaponizing rare earths and framing Beijing's export controls as geopolitical aggression rather than legitimate regulatory enforcement. At the BRICS summit in July 2025, Prime Minister Narendra Modi placed critical mineral supply chains at the center of his agenda. He called for international cooperation on key minerals and made a pointed statement that no country should use these resources as a weapon. He didn't name China directly, but given that the Sona Comstar incident had broken just weeks earlier, the target of his remarks was unmistakable to every leader in the room. The weaponization narrative has gained traction in Western policy circles as well, and there are legitimate debates to be had about how resource-rich nations should manage strategic commodity exports. These are real and complex questions, but in this specific case, the sequence of events is not complicated. An Indian company filed 30 false declarations. It organized a multi-country logistics operation to disguise material flows. It sold the diverted materials to military contractors across multiple countries. China's monitoring system detected the violations. China enforced its export control regulations. Calling that sequence weaponization requires setting aside the prior violations that triggered it. The harder truth for India is structural and will not be resolved by public statements. Its manufacturing sector needs high-purity rare earths. Its domestic refining cannot provide them at the required scale, purity, or cost. And the primary source of those materials is a country with which India has a complicated, often tense relationship. That's a genuine strategic vulnerability, and the Sona Comstar incident exposed it in the most public and damaging way possible. What this means for the world. The Sona Comstar case is one incident, but it sits inside a much larger transformation of how critical materials flow through the global economy. For Western governments and defense contractors, this case is a supply chain warning. The rare earth materials in your products may not be what the documentation claims. The Made in Malaysia label may conceal Chinese origin material laundered through multiple transit countries. China's isotope fingerprint system can now verify the origin of materials even after sophisticated disguise operations. The forensic capability is advancing faster than the evasion techniques. For any country trying to build supply chain independence from China, the lesson is uncomfortable but clear. The gap between Chinese rare earth processing capacity and the rest of the world remains enormous. That gap makes alternatives expensive, incomplete, and slow to develop. And when legitimate access becomes constrained, the pressure to find illegitimate routes increases proportionally. The Sonacomstar scheme, its scale, its planning, its multi-country complexity, shows what that pressure looks like when it reaches a breaking point. And for China, the successful deployment of these tracking technologies represents something genuinely new in the history of resource power. It's not simply that China holds the resource. It's that China has built an information infrastructure around the resource that extends its oversight far beyond the point of sale. The material carries Chinese jurisdiction with it, encoded in RFID tags and isotopic signatures, traceable across every border and every layer of disguise. For decades, the logic of resource power was straightforward. The country with the resource had leverage over the country that needed it. Simple, predictable, well understood. What China has built in the rare earth domain is something fundamentally different. It's not just ownership, it's traceability. Not just control at the mine. Control through the entire supply chain, all the way to the end product, in any country, at any stage. The ability to know, after the fact, whether the importing party honored its commitments, and the ability to enforce real consequences when it didn't. Sonacomstar thought it had found a clever workaround. 30 false declarations, warehouses in Malaysia and Vietnam, relabeled containers, laundered documentation, an elaborate multi-continent scheme to disguise the origin of materials that Beijing would never see again once they left Chinese ports. They were wrong. The tags remembered. The isotopes testified. And China saw everything. The age of untracked, unaccountable rare earth trade is over. The companies and countries that haven't fully absorbed that reality are still operating on assumptions that no longer hold. And the ones who try to test those assumptions, as one Indian company just discovered, will find that the consequences are swift, public, and expensive. The new rules of the rare earth world have been written, not in political speeches or diplomatic communiques, in RFID frequencies, in isotopic ratios, in quarterly compliance audits that have no tolerance for false declarations. And the country that wrote those rules controls more of what the modern world runs on than any other nation on Earth. If this video changed how you think about the raw materials inside your technology, about who controls them, how they're tracked, and what happens when nations try to play games with the rules, share it with someone who needs to understand what's really at stake. Subscribe and turn on notifications. Because the most important power struggles of the next decade won't be fought on battlefields. They'll be fought over what's in the ground and who gets to decide where it goes.